Okay, so question 5 is a little bit different because it's a more complicated looking spectrum and you only have the NMR to go on. So it looks kind of scary to start with, but actually the crucial thing is to read the question carefully and realise that they've told you what half the structure is already, and that makes it much more manageable. So the thing to do is not to ignore that information and plunge straight into the NMR, but rather to figure out what the structure must be, or at least a bit of it you know so far, and see if you can work out which peaks correspond to the bit of the structure you know, and then you only need to concentrate on the other ones, and it's a much more manageable problem. So it tells us that the starting point is 3-phenyl propanoic acid. So propanoic acid is that, and so 3-phenyl propanoic acid is just that with a benzene ring attached there. So that's our starting compound, and it tells us that we've esterified this with our alcohol D. So of course when that happens, that means that we lose this hydrogen and we replace it with our group R, and R is what we've got to find. So our first job is going to be to identify which of these peaks relate to this end of the molecule, and then we can just basically eliminate them from our inquiries and just concentrate on the rest of them. So the obvious starting point is the phenyl group. So we've got 5 hydrogens attached to that ring, because obviously this carbon has lost its hydrogen, and that corresponds exactly to this. So we can basically say, right, that's explained. Okay, because we've got 5 hydrogens in the aromatic region, 6.5 to 8 is the aromatic region. So that's what that peak, or that set of peaks is. We don't need to go into the details of the splitting, they won't ask you that for aromatic things, but that's clearly what that is. Now if we look here, we've obviously got a CH2 there and a CH2 there. So what we're looking for is 2 peaks, each with an area of 2, corresponding to the 2 hydrogens. And you can see we've got 3 to choose from. But we can easily tell which ones they are based either by thinking about the splittings or by thinking about the chemical shifts, and either of them will give you the same answer, but let's do it with the chemical shifts. So this one is next to a benzene ring, and if you consult your data sheet, HC benzene ring should be between 2 and 3, so that suggests one of those 2, but not that one. And again, the CH2 here is next to a carbonyl, and again your data sheet says HC carbonyl is between 2 and 3, so that strongly points to those 2 peaks corresponding to those 2 CH2s. And you can see that also fits in with their splitting, because the peak that comes from these 2 is going to be split as a result of those 2. So 2 hydrogens on the next carbon means that will give rise to a triplet, and similarly here, this peak is split by those 2 on the next carbon, so that will also be a triplet. So the 2 triplets. So that means those 2 correspond to those 2 CH2s there. So we can eliminate those from our inquiries. And that makes it look much more manageable now, because the R group that we've got to figure out just has 1, 2, 3, 4 peaks to account for. So where do we start with that? Well, where I would start is that something's going to have to be next door to that oxygen. There's going to have to be a carbon there, and if that has any hydrogens on it, it will give that characteristic HCO shift. Okay, so if you consult your data sheet, if you've got hydrogen attached to a carbon which has an oxygen on board, so that would be a carbon here, that should be 3.3 to 4.3 ppm. And if we look, we have indeed got a peak in that range, which is this one. And so instead of just putting R there, we can say, right, well what we appear to have is a CH2 attached there, because it's got an area of 2, and remember the area tells you how many hydrogens contribute to it. So it looks like we've got CH2 next to the oxygen, that's what the shift tells you, and again the splitting tells you something important as well, which is that next door to it there is a carbon with just 1 hydrogen on board, and that's what splits it into the doublet. No splitting from the oxygen, and so there must be a CH here. Okay, and we get all of that just from this peak. and that pretty much has to be right. So then we think, okay, well, let's go looking for this one. We know there's just one of it, so it has to be a peak with an area of 1, and that means it's got to be this one. Okay, because that's the only peak with an area of 1, and it's a triplet, which fits, because the next door carbon would be this one that has 2 on board, so that would account for the triplet splitting. But the thing that's really interesting about it is the shift is unusual. Between 5 and 6, if you look at your data sheet, that suggests it's an alkene carbon. So that strongly suggests that what we've got here is that. Okay. Moreover, the fact that that's only a triplet tells you that this hydrogen is just split by those two, and there is no hydrogen on board this carbon. Otherwise this would have more splitting than it does. So we must have 2 things attached there, but neither of them is hydrogen. So what could they be? Well, we look at what else is in the spectrum, and we see that we've got 2 peaks between 1 and 2, each with an area of 3. So those look like 2 methyl groups. You see peaks with an area of 3, you strongly suspect methyl groups. And of course, if we have 2 methyl groups, they could be there and there. Let me check, does that make sense? In terms of the shifts, well, yes it does, because those are HCr, because they're just attached to a hydrocarbon carbon, as it were, there. So the chemical shifts are right, the areas are right, as we said, but the splittings are also right, because the next door carbon is this one, it has no hydrogens on board, so you would expect those to be singlets. So that appears to fit. Therefore, that's the structure of the ester, which means that alcohol D, which is what the question actually asked you for, is just the alcohol end of that. So you just have OH, CH2, CH, alkene, and then the 2 methyl groups. And there is your answer. So they have set questions like that before, and people really didn't like them because they said this spectrum is just too complicated. But if you approach it the way we did there, identify the bit of the structure that they've already given you, match the peaks to that, and then just look at what you've got left, then you can get it right. Again, as with all these questions, once you've worked it out, you've now got to go through rigorously, and for each of these peaks, explain which carbon in the structure it comes from, explain its splitting, its chemical shift, and its area. But you do all of that and you get full marks. Okay, that's it.